Assalamualaikum warahmatullahi wabarakatuh. We are from class CDCS 1115A. We'll be presenting our group project for waiting line and queuing theory. We collectively as a group have chosen 4 fingers as our observation. Let me introduce you to our group members. Firstly, we have Naurin Alisa, Arisha Kistina, Nur Laila Khalilah, and Nur Izzati Nazira.
First, let's start with the introduction. The Four Fingers restaurant that we choose is located at S32, Level 2, Aeon Kota Baru Store, Lembah Sireh, Kampung Sireh, 15050 Kota Baru, Kelantan, and the operating time is from Sunday to Saturday from 10 a.m. to 10 p.m. Our observation time is from 5 p.m. to 6 p.m. and the number of server is 1 server.
Hi, I am Laila. I will briefly explain the characteristic of queuing system. A queuing system is when the customer arrive, wait in line, receive service and then leave. Example includes the banks and hospitals. There are 3 main characteristics such as arrival characteristic, waiting line characteristic, and service facilities characteristic. In this part, I will briefly explain the first two. Arrival characteristic explain how the customer enter the system. First, the calling population considered infinite, meaning there are many potential customers. Second, the customer arrives randomly, so arrival time are unpredictable. Third, the customer are patient, meaning they are willing to wait until they are served. Waiting line characteristic describe how the customer wait in the queue. In this system, the queue line is unlimited, so anyone can join the line. The queue discipline use a shortest job first, meaning the customer with the shortest service times are served first.
Next, I'm gonna be focusing on the service facility. The first one is the number of channel. Our observation has only a single channel system. Next, there is a multi-phase system where the customer has to go through a cashier counter and a pickup counter. And lastly, the number of waiting line is a single line. As you can see, this is the figure for single channel and multi-phase system.
Hello, my name is Rin, and for my part, I will explain about single channel queuing model. On the table above, here is the data that we observe from 4 fingers with lambda as customer arrival and mu is service time. For lambda, since the total arrival customer for 1 hour is 15 customer, therefore lambda equal to 15. For mu, based on the table before, shows that the total service time in 1 hour is 45 minutes. Now, we need to divide 45 with lambda, which is 15, and the total will be 3. To get total customer per hour, we need to divide 16 minutes with 3 since 1 hour equal to 16 minutes. Now, the total of mu will be 20. Now, we move to the calculation part. To find the average time customers spend in system, the formula is 1 divided with mu minus lambda, and the answer will be 0.2. To find the average number of customers in the system, the formula is lambda divided by lambda minus mu, and the answer will be 3. To find average time customers spends waiting in the queue, the formula is lambda divided by mu times mu minus lambda, and the total will be 0.15. To find the average number of customers in the queue, the formula is lambda square divided by mu times mu minus lambda, and the total will be 2.25. To find utilization factor for the system, the formula is lambda divided by mu, and the total will be 0.75. For the last calculation, we need to find the probability the server is not busy. The formula is 1 minus lambda divided by mu, and the final answer is 0.25. That's all from me.
When we are using the apps, first go to module and then select waiting lines, and then create a new file and choose exponential service time. Then enter the title, which is 4 fingers, and for the cost analysis, choose no cost. And then enter the parameter, which is arrival rate, service rate, and number of servers. And then enter the value, which is 15, 20 and 1. Based on the final output, our calculation is proven.
As for the conclusion, based on the results, the number of servers provided appears to be adequate because the utilization level of the servers remains below full capacity, which helps prevent long queues from forming and allows customers to be served efficiently. The customer's waiting time is relatively short. Therefore, it can be concluded that customers are generally satisfied and happy with the waiting time. And lastly, through this project, we learned how queuing theory can be applied to real-world service systems to evaluate performance and efficiency. We also gained a better understanding of how arrival rates, service rates, and the number of servers affect customer waiting time and system stability. And lastly, we learned the importance of properly balancing service capacity with customer demand in order to maintain smooth operations and customer satisfaction. That is all from us. Thank you for your time and thanks for watching.